Hey everyone, so now we are going to see how does the hashmap works internally with respect to Java 1.8 feature enhancement. So before proceeding further, would recommend you to go with the first two videos of the series where we have explained how does the hashmap work internally in terms of adding a data and retrieving a data. So here you can see the first line of code is we have created an instance of a hashmap. So whenever we create an instance of the hashmap, at the background an array of 16 buckets has been created. Here we have some entries of the map and we are assuming that each entry would return as the same hash code. As we know, when there are same hash code, hash collision occurs. And in case of hash collision, what JVM does, it internally calls the dot equals method and check the keys over here. If the keys are same, it will replace the new key with the old key, and if the keys are different, then it will place all the entry at the same index number. So as we can see, our key is different, so JVM has placed all these keys at the same index number with the linked list format. Now what I have to do, if I have to retrieve a data, the first one, so I'll simply perform an operation as map.cat and the key A, B, C. So what it will do, it will internally call the hash code method. It will return me some hash code. Then again, the further formula is that hash code and n minus 1. N is nothing but the size of the hash map, and it will return me some index. So then we are going to go at this index and then we will check that either this key and this key matches. So here we can see it matches, and then this data is being retrieved. Same thing, if I have to retrieve this data, we can see this data resides at the third node. So what it will do, we'll simply mention the key over here. JVM will again pass this key to the hash code. It will return some hash number. Then further residing to this formula, it will return as the index number. Then again we will check at the first node either the key matches or not. So here we can see the key doesn't matches. So JVM will traverse from this node to the another one. Again it will check over here, does the key matches or not. So here we can see it is XYZ, key doesn't matches, so it will traverse to the another. Here then it will see the key matches and then it will retrieve and get the data. So here you can see in this case we have to traverse from one linked list to another, another to another one. So it takes much time to retrieve a data. Here in a scenario there are only 3 linked lists, but what if there are n number of linked lists and a value resides at the nth element? So in this case the performance will be degraded and it will take much time to retrieve a data. So in such scenario, what hashmap does is internally it converts the linked list into the binary tree. And the binary tree in case of retrieving data is much faster as compared to the linked list. So this is the major enhancement in the internal working of the hashmap with respect to the 1.8 feature of Java. So whenever such scenario occurs, hashmap internally converts the linked list into the binary tree, which is much faster in retrieving data as compared to the linked list. Now let's see how does the binary tree is used to store and retrieve data. So let's assume we have few data over here. Now this data we are going to store with respect to the binary tree. So let's assume this is a node where we have stored the first value. Now I have to store the second value. So it will come and it will check either it is greater or lesser than 30. So we can say 40 is greater, then it will create a node over here. It will store 40 over here. Now let's check with another value. It will come, it will check either 10 is greater or lesser. So 10 is lesser, it will create a node over here and it will store 10 over here. Then again the next value, it is 60. We'll see either 60 is greater or lesser. The 60 is greater, then it will go over here. Here one more node is there, again it will be checked with this node, either it is greater or smaller, it is greater, then 60 will be stored over here. So data has been stored in this format in binary. Same thing would be used to retrieve a data. Now suppose I have to retrieve 10. So what I will do, I will come over here, I will check either 10 is smaller or greater. So we can see 10 is smaller, it will directly shift it to this node and a value will be retrieved. So here we can see we don't have to traverse in every node. With the help of the binary tree, we could perform the traversing quite quicker and earlier than linked list, and the performance is much better as compared to the linked list. So this is one of the important reasons that hashmap internally converts the linked list into the binary tree with respect to the Java 1.8 feature enhancement. That's all.